Hey guys, so we're going to go over vectors in the plane, just a quick intro. So you're initially given 2 points, your initial point, which is where the vector begins, and your terminal point, which is where the vector ends. And you'll know where the vector ends because it has an arrow on the end. Um, you can write a vector in component form, and you'll note that it has these triangular brackets, whereas points are in parentheses. So you'll know how to identify the difference between the two. You'll also see this little symbol on top from geometry, the representation of a ray. So also with the component form of a vector is the magnitude of a vector. The magnitude of a vector represents the length of the vector. If you look at the actual formula, it's just the distance formula, and it's represented by the two lines. So anytime you see these two lines, they're asking for the magnitude. So if you look at the example below, I'm giving you 2 points, the terminal and initial point. So I'm going to label this just following the formula as P sub 1, P sub 2, and the terminal point Q sub 1, Q sub 2. So the first thing it asks for is the component form of the vector. So from P to Q, I'm going to follow the formula. So good thing is to label it because we do get it mixed up sometimes, which is why I always label which one is which ahead of time. So I'm going to take Q1 minus P sub 1, which gives me -1 minus 4, and Q sub 2 minus P sub 2, which is 5 minus -7. And then from here, I will have my x component and y component of the vector, which will be -5 and 12. So that's the first part. And then from there, the direction also states to find the length of the vector, which is the magnitude. So to find the length or magnitude of the vector, note that the formula tells you distance formula, the square root of q sub 1 minus p sub 1 squared. We already found that because that was in the component form. So I can just take the square root of -5 squared plus 12 squared, which make sure when you punch this into your calculator, the -5 is in parentheses before you square it. Otherwise, it will come out negative rather than positive. So that gives you 25 plus 144, which is the square root of 169, and that will give you 13. So the length of the vector from here to here is 13. And finally, extra credit. There are two ways to write a vector. It can be written in component form. The other way to write it is also as a linear combination. So going back up to this component form, for PQ, I have -5. It's the x component, so I'm going to write it as I. And +12, it's the y component, so I'm going to write it as j. So the linear combination just signifies each letter tells you which type of component it is. When you get more into vectors, you will see that there are three-dimensionals. So let me just erase this real quick. So just kind of something to remember for future reference. The x vector is represented by I, the y vector is represented by the letter j, and when you're in three-dimensional, you'll have a z vector, which is represented by k. All right, guys, I hope this helps. There will be more on 603 in the next slide.